China is building a dam 3 times bigger than the Three Gorges Dam, and it's going to cost $167 billion. To put that in perspective, that's enough money to build the Burj Khalifa, the world's tallest building, over 1,100 times. You heard that right, 1,100 Burj Khalifas for a single hydroelectric project buried deep in the mountains of southwestern China. Most people have never heard of it. But what's being built on the Yarlung River right now will rewrite every record humans have ever set in engineering. And before you understand why this dam is so extraordinary, you first need to understand exactly where it's being built and why that location alone makes this the most ambitious construction project on the planet. What is the Lower Yalong Hydropower project? You're standing in one of the deepest river gorges on Earth. The walls of the canyon rise over 5,000 feet above you on both sides. The Yarlung River is roaring beneath your feet, violent, relentless, and completely untamed. This is Sichuan Province, southwestern China. And this is where China has chosen to build the most expensive infrastructure project in human history. The Lower Yalong Hydropower project isn't a single dam. That's the first thing most people get wrong. What China is building here is a cascade, a coordinated chain of 4 massive dams stacked along the lower stretch of the Yarlung River, Liangheku, Yangfenggu, Kala, and at the very bottom of that chain, the crown jewel Yasha Dam. Each dam feeds the next. Each reservoir backs up into the one above it. Together, they function as one single, interconnected power machine of a scale the world has never seen. But the number that stops people cold isn't the size, it's the price tag. $167 billion. Committed, approved, already being spent. To put that in context, the entire Three Gorges Dam, which held the record as the world's largest power station for nearly 3 decades, cost roughly $31 billion to build. The Lower Yalong project costs more than 5 times that, and China didn't hesitate for a single day. The entity behind this project is Power China, one of the largest state-owned construction conglomerates on Earth, backed by the full financial and political weight of the Chinese government. This isn't a private gamble. This is a national directive. Beijing decided this dam would be built, and that was the end of the conversation. But here's what makes this more than just an expensive project. China has a promise to keep carbon neutrality by the year 2060. And the math only works if China can generate clean electricity at a scale that no country has ever attempted. The Lower Yalong Cascade isn't just a dam. It's the backbone of that promise. It's the infrastructure that makes the whole pledge possible. And yet the moment construction crews began moving into those canyons, a set of problems emerged that no amount of money or political will could simply bulldoze away. The engineering. How do you build this? You've never seen terrain like this. The Lower Yalong Canyon isn't just remote, it's hostile. The walls of the gorge drop thousands of feet at near vertical angles. The rock is fractured, unstable, and riddled with fault lines. The river itself is one of the most powerful waterways in all of Asia, carrying billions of gallons of water through a channel so narrow and so deep that sunlight barely reaches the bottom. And China decided to build 4 of the largest dams ever constructed, right here, in the middle of all of it. Before a single pour of concrete could happen, engineers faced a problem that sounds almost impossible. You cannot build a dam in a river that's still flowing. The Yarlung River had to be moved. Not redirected slightly, moved entirely. Construction crews had to blast and bore massive diversion tunnels straight through the canyon walls, tunnels wide enough to swallow a 6-lane highway to reroute the full force of the Yarlung River away from the Pastes construction site while the dam foundations were laid. The scale of that single task alone would qualify as a major engineering project in any other country on Earth. But moving the river was just the beginning of the nightmare. The geology beneath the Yarlung Gorge is among the most complex and dangerous on the planet. Sichuan Province sits on a collision zone between the Indian and Eurasian tectonic plates. The ground here doesn't just shift, it ruptures. Engineers drilling into the canyon walls discovered rock formations that behaved in ways their models hadn't fully predicted, zones of shattered stone that would crumble under the pressure of a structure as massive as Yasha Dam. Every single foundation anchor, every drill shaft, every concrete injection point had to be redesigned on the fly. deep inside a canyon with no road access, no flat ground, and weather that swings from brutal summer heat to freezing mountain winters within the same construction season. Then came the concrete problem. Yasha Dam is being built as a double curvature arch dam, one of the most structurally demanding designs in all of civil engineering. An arch dam doesn't just sit on the riverbed and hold water back with sheer mass the way a gravity dam does. It curves. It transfers the colossal pressure of the reservoir outward and downward into the canyon walls on both sides. The rock doesn't just support the dam, the rock becomes part of the dam. Which means if the rock fails, the dam fails. And in a canyon this geologically unstable, that relationship between concrete and canyon wall had to be engineered with a precision that bordered on the obsessive. The concrete itself became its own crisis. At high altitude, in a gorge where temperatures can swing 60 degrees Fahrenheit between day and night, standard concrete mix formulas are useless. Concrete cures through a chemical reaction that generates heat. In thin mountain air with extreme temperature variation, that reaction becomes unpredictable. The concrete can crack before it ever sets. Chinese engineers developed entirely new high-performance concrete formulations specifically for this project, mixes that could handle the thermal stress, the altitude, and the sheer volume of material being poured. Because at Yasha Dam alone, the volume of concrete being placed into that canyon is measured not in thousands of cubic yards, but in tens of millions. But the most extraordinary engineering decision of the entire project is one you'd never see from the outside. The powerhouses, the engine rooms that will actually generate the electricity, are not sitting on the surface of the river. They are buried inside the mountains themselves. Massive underground caverns, some of them over 300 feet tall and nearly 2,000 feet long, have been hollowed out of solid rock deep inside the canyon walls. The turbines, the generators, the transformer halls, all of it invisible, entombed in stone. The reason is both brilliant and sobering. On the surface, in a seismic zone this active, a powerhouse is a target. Underground, surrounded by hundreds of feet of solid mountain, it is protected. The engineers buried the power plant because the ground above it cannot be trusted. And coordinating all of this, the diversion tunnels, the foundation work, the concrete pours, the underground cavern excavations simultaneously across 4 dam sites in one of the most inaccessible regions of China, required a workforce and a logistics chain that is almost incomprehensible in its complexity. At peak construction, tens of thousands of workers are on site across the Lower Yalong cascade. Entire temporary cities had to be built in the gorge to house them, roads blasted into cliff faces, suspension bridges thrown across the river, cable systems rigged to move equipment down sheer canyon walls to work sites that no vehicle could reach. There is no easy way into this gorge. Every piece of steel, every bag of cement, every drill bit and bolt had to be carried in, down into one of the deepest canyons on Earth, and that supply chain has to keep moving, without interruption, for over a decade. But as extraordinary as the construction is, nothing quite prepares you for the moment you actually understand the size of what's being built. The size, putting it in perspective. You think, you understand large. You've seen pictures of the Three Gorges Dam, that vast gray wall of concrete stretching across the Yangtze River. A structure so massive, it's visible from space, and so famous, it became the symbol of Chinese industrial ambition for an entire generation. You think you know what big looks like. You don't. Not yet. Yasha Dam, the anchor structure of the Lower Yalong cascade, stands over 920 feet tall. That is taller than the Eiffel Tower, taller than the Chrysler Building in New York City. You could stack 2 statues of Liberty on top of each other inside that canyon, and the top of Yasha Dam would still be looking down at them. And this isn't a gentle slope of earth and rock. This is a precision-engineered arch of concrete, curving in 2 directions simultaneously, holding back a reservoir of water with a force that is almost beyond human intuition to grasp. But the height is only part of the story. The reservoir that Yasha Dam creates stretches back upstream for over 100 miles. 100 miles of flooded canyon, submerged valley, and drowned river gorge, a man-made inland sea sitting more than 8,000 feet above sea level in the mountains of Sichuan. The volume of water held behind Yasha Dam alone is measured in the billions of cubic feet. And because the Lower Yalong cascade is a chain Liang Heku above it, then Yangfangu, then Kala, then Yasha, at the bottom the reservoirs stack into each other, creating an unbroken corridor of controlled water running for hundreds of miles through some of the most rugged terrain on the planet. Then came the number that stops engineers cold. The concrete volume poured into Yasha Dam alone exceeds 35 million cubic yards. 35 million cubic yards. To put that in a frame, you can actually feel that is enough concrete to build the Hoover Dam over 30 times. You heard that right. 30 Hoover Dams worth of concrete poured into a single structure inside a canyon that barely lets sunlight reach its floor. And the cascade as a whole, all 4 dams combined, represents a total construction volume that dwarfs every single infrastructure project currently underway anywhere on Earth. The Three Gorges Dam, for all its legendary scale, used approximately 12 million cubic yards of concrete in its main structure. The Lower Yalong project uses nearly 3 times that across its cascade. The 3 times bigger claim in the title isn't marketing, it's math. But size without purpose is just spectacle. What makes the Lower Yalong project genuinely historic isn't the height of the dam or the length of the reservoir. It's what all of that concrete and stone and water is ultimately designed to do. Because when you understand the generating capacity that this cascade is being built to unlock, the $167 billion price tag stops feeling shocking. It starts feeling inevitable. The generating capacity, why this changes everything. You want to understand what 16,000 megawatts of electricity actually means. Not in the abstract, not as a number on a page, but as a real physical force that reshapes how an entire civilization powers itself. So here's how you feel it. Right now, the average American coal-fired power plant generates somewhere between 500 and 1,000 megawatts of electricity. It burns millions of tons of coal every single year to do it. It employs hundreds of workers. It produces enough pollution to measurably shorten the lives of people living within miles of its smokestacks. And it runs 24 hours a day, 365 days a year, just to keep the lights on for a mid-sized American city. The Lower Yalong cascade, when fully operational, will generate the equivalent of somewhere between 16 and 20,000 megawatts of installed capacity. That means this single river system, this one chain of 4 dams in a canyon most people on Earth have never heard of, will produce enough electricity to replace between 16 and 40 coal-fired power plants. Simultaneously, permanently, with zero fuel cost and zero emissions once the infrastructure is in place. But that number alone doesn't capture what's actually happening here. China's carbon neutrality pledged the commitment to reach net zero emissions by 2060 is one of the most consequential environmental promises ever made by any government in human history. China is currently the world's largest emitter of carbon dioxide. It burns more coal than every other nation on Earth combined. And the path from where China stands today to where it needs to be in 2060 requires a clean electricity generation build-out so massive, so fast, and so sustained that most Western energy analysts consider it almost incomprehensible in scale. The Lower Yalong cascade is not a piece of that puzzle. It is the cornerstone. Every kilowatt hour generated by the Yarlung River is a kilowatt hour that doesn't come from a coal plant. And at the scale this cascade operates, running at full capacity for decades, the cumulative carbon displacement is measured not in millions of tons, but in billions. Chinese government projections estimate the full Lower Yalong system will eliminate the equivalent of over 50 million tons of carbon dioxide emissions every single year. Every single year. For the entire operational lifespan of the project, which is measured in centuries, not decades. Then came the transmission challenge. And this is where the engineering story takes a turn that most people never hear about. The Lower Yalong cascade sits deep in the mountains of Sichuan province, thousands of miles from the coastal megacities of Shanghai, Guangzhou, and Shenzhen, where the electricity is actually needed. Generating 16,000 megawatts of clean power in a remote mountain gorge is extraordinary. Getting that power to 300 million people living on the other side of China is a completely separate engineering problem. one that required China to simultaneously develop and deploy ultra-high voltage direct current transmission lines, some of the most advanced electrical infrastructure ever built, capable of moving electricity over distances of over 2,000 miles with minimal loss. You are not just watching a dam being built, you are watching an entirely new national energy nervous system being wired together in real time with the Lower Yalong cascade as its beating heart. And China has done this before. The Three Gorges Dam proved the model. The Lower Yalong project is the model running at 3 times the ambition. But here is the part that the official announcements leave out. The part that engineers, ecologists, and geopolitical analysts have been quietly warning about since the moment this project was approved. Because for everything this dam promises to deliver, and the promises are real, and the engineering is genuine, and the clean energy math is sound, there is another set of numbers, a darker set. Numbers that don't appear in the Power China press releases. Numbers that tell a completely different story about what it actually costs to build something this big in a place this fragile on a river that doesn't belong only to China. The controversy, what they're not telling you. You've seen what this dam can do. Now you need to hear what it could destroy. The Yarlung River Canyon sits inside one of the most seismically violent regions on Earth. In 2008, a single earthquake less than 200 miles from this construction zone killed nearly 70,000 people in minutes. That was the Wenchuan earthquake. And the fault lines that caused it run directly beneath the Lower Yalong reservoir chain. But here's what makes that fact genuinely terrifying. Large reservoirs don't just sit on top of fault lines. The weight of billions of cubic feet of water pressing into fractured rock actually triggers earthquakes that wouldn't otherwise happen. It has a name: reservoir-induced seismicity, and it has already been documented at the Three Gorges Dam. China's own geological surveys have acknowledged the risk here. And still, construction accelerated. But the seismic risk was only the beginning. If Yasha Dam ever experiences a catastrophic failure, the wall of water released wouldn't just be a flood. At over 900 feet tall, it would be an extinction event for every community sitting in that downstream corridor, millions of people with nowhere to go and no warning system fast enough to save them. China has never published a full worst-case failure study for this project. That silence tells you everything. Then came the cost that never appears in any budget. The Yarlung Canyon is one of Asia's most biodiverse river ecosystems, species that evolved here over millions of years, found nowhere else on Earth. The moment those reservoirs fill, their countdown begins. There is no fish ladder, no hatchery program, no conservation offset that independent ecologists believe can replace what is being permanently destroyed. And the communities, many of them Tibetan ethnic minorities who have lived in these canyons for generations, were relocated under compensation agreements that have never been made public and cannot be independently verified. $167 billion. And that's only what China is admitting. China's bet on hydropower and what it means for the world. You need to understand that the Lower Yalong project isn't the end of this story. It isn't even the biggest chapter. While the world has been watching, China has been quietly damming every major river flowing off the Tibetan Plateau, the single largest freshwater source on the planet. The Yarlung Zangbo project, currently being developed on the world's deepest river gorge, is projected to generate 60 gigawatts of electricity. 60. The entire Three Gorges Dam generates 22.5. You heard that right. One project on one river, producing nearly 3 times the output of the structure that held the world record for 30 years. But here is what no one is saying loudly enough. Every one of these rivers flows downstream into India, Bangladesh, Myanmar, Vietnam, Cambodia, and Laos. Nations that feed hundreds of millions of people from the same water China is now learning to control. China has signed zero-binding international water agreements with any of them. It controls the tap. And the downstream nations have no legal mechanism to stop it. And it wasn't just the geopolitical tension that was building. China is now the world's largest exporter of dam construction, deploying this exact model across Africa, Southeast Asia, and South America through the Belt and Road Initiative. What started as one project on one river in Sichuan has become a global infrastructure philosophy. The Lower Yalong Dam isn't just China's biggest bet, it's the blueprint. What this dam actually means. You're back at the edge of that canyon, the same gorge you stood in at the beginning. Except now, you know what's buried inside those walls, the tunnels, the caverns, the turbines, the tens of millions of cubic yards of precision-engineered concrete holding back a reservoir the size of a small nation. You know what it cost to build it, and you know what it cost to justify it. Here is the number that ends the argument or starts it, depending on where you stand. When the Lower Yalong cascade reaches full operational capacity, it will generate enough clean electricity every single year to power a country the size of Argentina permanently, without burning a single gram of coal, without producing a single barrel of oil. The carbon displaced by this one river system over its projected operational lifespan exceeds the total carbon output of most European nations over the same period. That is what $167 billion buys you. But then came the hardest truth of all. The Yarlung River that existed before this project, wild, unbroken, roaring through one of the deepest canyons on Earth, is gone forever. The species that lived in it, the communities that grew alongside it, the ancient, unmapped ecosystem that took millions of years to build, gone. Not damaged, not reduced, gone. China built the most powerful clean energy machine in human history, and it may have destroyed one of the last truly wild river systems on the planet to do it. Whether that trade was worth it, whether any trade at that scale is ever worth it, is the question that will outlive every engineer, every politician, and every turbine in that canyon. The dam is built, the river is gone, and the lights are on.